Okay, so this is example 25 in the textbook. It's a really standard question on trapezium rule. You can see that we've got our graph is y equals sec x, and it's drawn over here. And we've got a region R, and we're told it's bounded by the x-axis, the y-axis, and the line x equals 3, so we're going between 0 and 3. And then we've got a table of values. So these 5 x values correspond to those split ups, and there's not actually 4 in the region because there's 5 values, so there's only 3. So it's 1, 2, 3, 4, 5 different x coordinates, and therefore 5 different y values. And a few of them are filled in for us, and job number 1 is to fill the rest of the table in. One thing we can do, which is fairly easy, is we can just figure out what is sec of pi over 6 is, remembering, of course, that sec is 1 over cos, so it's 1 over cos of pi over 6, and I can just type that in the calculator. So 1 over cosine of pi over 6. And I get 2 root 3 over 3, or actually you can see we're working in decimals. So 1.155. Let's go for 3 decimal places. If you have a lot to fill in, or even if you just have 2 to fill in, it's actually quicker to do this using the table function. So if you remember the table function, we hit menu. On these calculators, it's number 9, and then we type in our function. Obviously, again, we can't type in sec, so we type in 1 over cos of x. Close the brackets, that's our function. Don't need a second one. Start, end, and step. Got to think about that a little bit. I'm beginning at 0. I'm ending at pi over 3, so I can hit shift and then pi, and then the fraction button and 3. Notice you don't get the nice looking fractions, you get this weird kind of backwards L shape, but this means pi over 3. And the step, well, we're going up in pi over 12s. If you look at the gap between 0 and the first one, you can see that straight away. So the step is pi over 12. And you can see we're doing some numerical work, and so it turns these into decimals. But for the sake of what we're doing, that doesn't matter, because I don't need exact values. I need the decimal numbers. I need the approximations. And you can see we get a y value of 1, 1.035, 1.155, which is what we got before, and then 1.414. So I can pop these in, 1.155 and 1.414. And then the next one is 2, because it is calculating these exactly. So the calculators are a really key part of sorting this out. Don't mind the school bell. And then part B just says use the trapezium rule with all the values of y in the completed table. So I have my completed table, and I have my trapezium rule. And my trapezium rule, remember, is half h brackets y0 plus 2 lots of all the rest. And I've got y1, y2, y3, and y4 here. So y1, y2, and y3 get doubled up, and then y4 doesn't get doubled up because it's the end of the interval. And h is the width of these things. So h is pi over 12. And that's it. I just need to retype this in the calculator with all these values in. Sadly, there's not really an efficient shortcut for pulling them out of the table, but I only need to use these values to 3 decimal places anyway, so I just need to do a bit of retyping. So if I go back to normal calculator mode, I'm just going to type in half times by h, which is pi over 12, times by brackets, and then y1 is 0 plus 2 lots of, and then y1 is 1.035 plus 1.155 plus 1.414, close those brackets, plus 2, close those brackets, hit equals. So I've literally just typed this in as it says here straight into my calculator. and I get 1 point, and it says to 2 decimal places, so 3, 4. And that's it. Okay? It's just a calculator problem. You just need to know what order to type everything in. And remember, this formula right here is in the formula book if you need a gentle reminder of the fact that these middle values double and the end ones don't. But it's also kind of common sense from how we figured out these trapeziums. The final thing to notice is C, explain with a reason whether your estimate is under or over. So we just need to look at our curve here to establish what we think is going to happen. So if I just sketch in those trapezium, you can see that my trapezium, because this curve is kind of going that way, all of my trapezium lines are going to be slightly above the curve. So the area I have is definitely going to be a slight overestimate. And it's going to be an overestimate because this curve is increasing, so my trapezium lines are above it. And whether it's over or under is basically determined by whether the section of curve is concave or convex, as we kind of looked at before when we were looking at properties of different curves and all the calculus stuff about points of inflection and all of those bits and pieces. So we can see this is going to be an overestimate. And the estimate will get better the more points you put in, so the more strips you include. This only has 4 strips, so it's a reasonable but not really accurate estimate. And that's it. You need to know how to use your calculator efficiently, what the formula is telling you, and that's the trapezium rule sorted.